Organized by the Department of Physics, the IS University, Jaipur. Recently, the research in physics has witnessed a booming development due to increasing interest in areas like microwave techniques and their radiation hazards towards humanity. Therefore, this conference has been organized to draw attention of the researchers towards the application, new possibilities of adopting optical communication systems and to minimize the radiation hazards reported by...
I now request Dr. S.B. Chakrabarty, our keynote speaker. Dr.
Dr. Ashok Gupta to extend floral greetings to our keynote speaker, Dr. S.B. Chakrabarty.
Namaskar. Dr. Chakrabarty, distinguished educationists and researchers from all over the country, delegates, my colleagues on the dais of the days, and dear students. I extend a very hearty welcome to all of you today when we get the National Conference on Recent Trends in Microwave Techniques and Optical Communication inaugurated. I must congratulate the Department of Physics for having taken up this lead to organize a conference on a contemporary topic, which is the need of the hour. The IS University is not a very old phenomenon in the educational world. We started as a girls' college in 1995 with just 52 girls and 7 members of staff. After a few years, we became an autonomous college. The NEC accredited that an autonomous college an A+ status. And in 2009, the Ministry of Human Resource Development, Government of India, declared the International College for Girls as a deemed to be university. Soon we were put to scrutiny by a committee constituted by the MHRD to review the functioning of the deemed universities. And I take pride in stating that we are amongst the first 38 universities which the committee said meet the standards and norms fixed by the University Grants Commission. The two-day national conference organized by the Department of Physics of this university will bring together and disseminate the research ideas carried out by various institutions and to share the resultant findings, I'm sure. The conference has been organized to provide an opportunity of enlightening discussion on the latest trends in the fields of microwave physics, techniques, and optical communication between eminent scientists, educators, teachers, research scholars, and students of science and engineering. This conference, I believe, will serve as a platform to promote high standards of research and training towards various microwave techniques. I'm sure that the 2 days of the deliberations will benefit all the delegates and students. So, ladies and gentlemen, on behalf of the IS University, I once again welcome you all to this university, this new university. It's not a very old institution, and I'm sure your stay for 2 days and the deliberations of the conference will be quite fruitful. Yesterday only we have received a message from the Chief Minister of the state, which I would like to read out. It gives me pleasure to note that the IS University Jaipur is organizing an interdisciplinary national conference on recent trends in microwave techniques and optical communication in February 2015. It is never easy for a layperson to appreciate the intricacies of high energy physics. Nonetheless, microwaves and their utility in the day-to-day applications, such as in communication and in home appliances, is well known. I'm sure the conference shall have sessions that stimulate vigorous discussions and prove to be beneficial to all participants. I wish the conference the very best. Thank you very much.
May I now invite Professor Pradeep Bhatnagar, Dean, Faculty of Science, the IS University, to give the audience an overview of the various departments.
Namaskar, dignitaries on the dais and the audience, resource persons, young researchers and delegates from different parts of the country. It is my pleasure to welcome you all in this 2 days conference. I take this opportunity to familiarize you from the progress made by the science faculty of this university within a short span of 5 years, that is from 2010, when autonomous ICG became IS University, deemed to be the university. The science faculty of this university comprises 5 departments: chemical sciences, computer sciences and IT, environmental and life sciences, having 5 disciplines: biotechnology, microbiology, botany, environmental science, zoology. This department is also providing COSD 1-year diploma course in intellectual property rights and patents. Physical and computing science with 4 disciplines: physics, mathematics, statistics and geography, and home science. All the departments are running UG, PG and PhD programs. Faculty is doing research in different thrust areas. In chemical sciences, research is being conducted in the heterocyclic chemistry, coordination chemistry, environmental chemistry, computational chemistry, and in Department of Environment Science and Life Sciences, the thrust area for the research are pollution monitoring, cell and molecular biology, developmental biology, microbial diversity, plant diversity, bioremediation, phytochemistry, ecological restoration, toxicology, environmental toxicology and cancer biology. Research facilities developed during last 5 years are animal cell culture, probably only in the state, and the plant tissue culture and molecular labs. Faculty and students of Home Science Department are actively involved in the teaching and research in community health, nutrition and clinical therapeutic nutrition. In the Physics Department, the research is being carried out on dietetic studies of chemical and microwave frequencies. Software engineering, cloud computing, database, data mining are some of the thrust areas of research in which the faculty are in progress in the department of the computer science and computer science. In the short span of 5 years, our science faculty has handled 4 major projects and 51 minor projects sanctioned by DRD, UGC, DST of State and IS University. Similarly, we have published quite impressive number of research papers, 191 in international journals and 147 in national journals. Impact factor of which were running from 0.63 to 41.2. The science faculties, in science faculty, 15 students have been awarded PhD degree, and at present 69 students are registered in the PhD program. Faculty of Science has also organized 31 conferences including workshops in the short span of the 5 years. The science faculty comprises very young, energetic 75 faculty members, which includes associate professors, assistant professor and senior assistant professors. Besides this, we invite senior reputed faculty from various universities and research organizations from the different parts of the country. I once again welcome you all this conference and wish you a very happy learning time at Jaipur. Thank you once again. Jai Hind.
Thank you, sir. Now I request Professor K.S. Sharma, advisor and conference convener, to enlighten us about the conference.
Keynote speaker Dr. S.P. Chakravarti, Honorable Vice Chancellor Dr. Ashok Gupta, Dean of the Faculty Professor Pradeep Bhatnagar, Head of the Department of Physics Dr. Ritu Jain, Director and Registrar Dr. Raki Gupta, the Honorable guests, distinguished speakers, Deans of the Faculty, Professor M.K. Sharma, Faculty of the University present here, students and delegates from different parts of the state. This is my proud privilege to say something about the conference. I welcome Dr. Chakravarti to this conference and thank him for consenting to give a keynote address, and just on the short notice when Professor Deepak Bhatnagar introduced him to us, we are really grateful to him for accepting our request on such a short notice. This conference is the third event under the Silver Jubilee celebrations of IS University Network. The India International School, the first institution of this network, is completing 25 years, and the IS University, established as International College for Girls, is completing 20 years this year. So these celebrations have meaning that way. This national conference on recent trends of microwaves, microwave technique and optical communication was conceptualized in view of great impact of these technologies in our day-to-day life, and necessary background for holding such a conference was available with the university, as Department of Physics is offering courses on microwave electronics as well as optical communication. Moreover, the material studies, research on the dielectric studies of materials and say food materials such as food grains, oils, oil seeds and pulses, etc. This is being conducted in the department. Microwaves have been used for defense applications, for radars and communication purposes, for scientific applications such as dielectric measurements and the study of molecular behavior of materials, and for civilian applications such as telephones, television, wireless communication, etc. for last 75 years. The purpose of this conference was to consolidate the new techniques which have arisen within last 25 years. The recent developments in communication systems with the development of efficient antennas, the satellite communication systems, planetary communication, the new techniques for measurement of dielectric properties such as network analyzer, impedance analyzer, for permittivity measurements. They have almost completely replaced the traditional methods of microwave benches and say cavity resonators. Similarly, the time domain reflectometry is also a new technique for dielectric measurement which has come up in last 20-25 years. Aquametry is another area which has emerged in the past 20 years and mostly used for agriculture and food science purposes. By measuring the dielectric permittivity, we can estimate moisture level of crops and food materials, and this can be done non-destructively or through remote sensing by using a moisture meter. With the knowledge of the moisture level, state for the safe storage of crops can be easily decided. The property of dielectric heating by microwaves can be used to save stored grains from being spoiled by insects or fungi. The property of selective heating of microwaves has been used for killing insects inside dry fruits and other fruits like apple, etc. The grading of fruits can also be done by estimating their quality through dielectric measurements. The determination of quality of soil and remote sensing are such other areas of microwaves which have been used in agriculture, for usefully used for agriculture purposes. Chemical reactions and forging of metals and atmosphere of microwaves have been found to take place at much faster rate and more efficient. The television, cell phone communication, internet and data communication, and microwave oven are now the essential commodities of our life. However, a caution is needed against the ill effects of excessive use of mobile phone and exposure to electromagnetic radiation. Optical communication is another area to be covered in this conference. The optical fibers have now almost completely replaced the old microwave links and cable networks. The importance of optical communication can also be realized from the following two facts. The UNESCO has recognized the year 2015 as the International Year of Light and Light-Based Technologies. To commemorate the anniversary of notable research on the nature of light and light-based technologies, a logo has also been given by UNESCO for the International Light Year 2015, which you can see on slide. Say, this is on 20th December 2013, the United Nations General Assembly 68th session proclaimed 2015 as the International Year of Light and Light-Based Technologies, and most of the countries are taking part in these celebrations. The global secretariat of these celebrations have been set up at Abdul Salam International Center for Theoretical Physics at Triste, Delhi. These are the scientific anniversaries. In 1015, this was work on optics by L. Haytham. 1815 is known for wave nature of light given by Fresnel. Then 1865 is known, the Maxwell given the electromagnetic theory of light. 1915 is known for general theory of relativity, which tells that the light can take curved paths while around the Earth or another planets. Then 1965, which is completing the Golden Jubilee, that is the Golden Jubilee for the cosmic microwave background, and also Gauss' discovery for optical fibers. So, in order to commemorate all these important anniversaries, the UNESCO has declared this year as the Light Year. This is the logo which has been given by the UNESCO. This is another logo because previous one was combined with the logo of the UNESCO. These are the three forms given by logo. Then another important feature about the optical communication is that recently the Harvard scientist Lene Howe and her team have successfully not only slowed down the light from the speed of 1,86,282 miles per second in air to a speed of only 38 miles per hour in a Bose-Einstein condensate of argon, but also they have succeeded in completely stopping the light. This picture shows the stopped light. So in fact, what they do, they take a carbon, they take argon atoms and they condense it. So Bose-Einstein condensate is produced in the form of a cigar, and then laterally a wave of laser was injected. Then when this wave of laser is injected laterally, then a axial laser beam was slowed down, and by withdrawing the transverse laser beam, they completely stopped the light. So this is a new discovery which will open new fields for, say, what we call quantum computers, and as well as for safe communication purposes. So this will take the new mode. In addition to the inaugural session in this conference will have 4 technical sessions, 2 sessions for oral presentations by delegates, and 1 poster session. There shall be 9 invited talks in 4 technical sessions. We have with us Dr. S.B. Chakravarti, Head Antenna Division, ISRO Ahmedabad, Professor D.C. Dubey from IIT Delhi, Professor J. Behari from JNU New Delhi, Professor Kumkarne from SRTM University, Nanded, Dr. S.N. Joshi, Emeritus Scientist from CD Plani, Dr. Suchandan Pal from CD Plani as our resource persons for this conference. I extend all of them a warm welcome. Professor K.P. Maheshwari from Devi Ahilya University, Indore, Professor Sancheti, Vice Chancellor Manipal University, Jaipur, Professor Deepak Bhatnagar, University of Rajasthan, Jaipur, will also be joining us to give invited talks in this conference. I am grateful to all of them. Dr. R.K. Khanna, Dean Research, Vivekanand Global University, Jaipur, Professor Rasmi Sisodia, University of Rajasthan, Jaipur, and Dr. K.B. Sharma, Principal Subodh College, Jaipur, have also consented to be part of this conference. I thank them all for consenting to be here. Further, our thanks are also due to Professor Ajay Ghatak, who actually drawn our attention towards the year of light year being declared by UNESCO. Professor Tyagarajan from IIT Delhi, Professor Opin Kalla, Director Radio Science and Research Center, Jodhpur, Professor S.C. Malhotra from Ambedkar University, Aurangabad, Professor N.K. Jaiman from University of Kota, who were to attend this conference, but for certain reasons they have not been able to come here to participate in the conference. We thank them all. About 100 delegates from all over the state are attending this conference. I welcome them all to this conference. There shall be 18 oral presentations, 10 in the faculty category and 8 in the student category. The best presentation of each category will be awarded. In the poster session, in all 26 posters are to be presented, 10 in the faculty category and 16 in the student category. One best poster in the faculty category and first and second posters in the student category shall be awarded. I am sure the conference will prove to be useful to all the participants. The conference will also provide an opportunity for knowledge dissemination and experience sharing to the resource persons and delegates. I hope your stay at Jaipur will be comfortable. Once again, I welcome you all to this conference. Thank you.
Ladies and gentlemen, we are honored to have amongst us Dr. S.B. Chakrabarti, Head, Microwave Sensors Antenna Division, Ahmedabad. A PhD in Microwave Engineering from IIT Kharagpur, Dr. Chakrabarti has also been a lecturer in Department of Electronics and Telecommunication Engineering at NIT Silchar. He has been deputed by I would now request Dr. S.B. Chakrabarti to kindly address the gathering.
Dignitaries on the dais, the distinguished participants, ladies and gentlemen. I feel very much proud and honored having been invited to deliver the keynote speech on behalf of Space Application Center and Indian Space Research Organization, Ahmedabad, in this important forum. For that, I am very much thankful to the organizing committee for inviting me to come to Jaipur and to participate in this conference organized by IIS University. And in this context, I would like to congratulate the authorities of IIS University and particularly the Department of Physics for the meticulous organization of this event. And I am sure this conference will provide a very good platform to all the participating researchers, students, academicians, and the professionals to interact and share their experiences, and this will facilitate to enhance your knowledge base and to get a future direction to the endeavor of research in the microwaves and optical techniques. Now, for this, based on the theme of today's conference, I will focus my discussion on the electromagnetics in our day-to-day life. Now you see the electromagnetics, if you see our activities, starting from the time you wake up in the morning and to the time when you are going to bed, you are using the electromagnetic appliances almost in all of your activities. Now, this is that electromagnetics and its appliances. This background is the research of more than 100 years. And I wonder, sometimes I wonder if this discovery of electromagnetics and its technology behind for last 100 years, it would not have been there, then where would have been our civilization? The electronics and electromagnetics, they have made our life very easy and very sophisticated. And to be very frank, all these electromagnetics devices, electromagnetics, that appliances, a lot of research and lot of scientific studies that have occurred until there are a lot of emerging technologies, they are coming up. And in this context, I like to ask question to ourselves, where we stand as compared to the global nation, whether we have attained the self-reliance in these technologies. The answer is no. Till we have to depend on some import from the developed countries. So in order to, that is to fulfill the mission of Make in India, we must strive for our indigenous development of all these things. And for this, all the communities, the scientific communities, engineering communities, we should strive hard so that we can bring the self-reliance in this technology. And in this case, and in this situation, this role of universities is very important to impart the relevant education and to ignite the young stars, that is young bloods, to take up the research in these fields. So, this is the background of my talk today. So just to begin with, what I like to say that this presentation, that is the materials are there from the books, articles, internets, and that is my organization ISRO. I have taken many materials from there. So I acknowledge all the sources, and omission of any acknowledgement is, if any omission by unknowingly, if it is any unintentional omission, so I like to acknowledge all this, whatever the material I am going to present today. So just to start with the presentation, we should look back the history of the electromagnetics. This forum, we like to commemorate all those pioneers in this field, and especially that is our contribution of India those days. So this I like to shortly cover those topics, followed by the different electromagnetic spectrum and its application. Now, as I said, when you are watching your radio, watching TV, talking, using your cell phone, when you are cooking, when you are in the airport, and when you are traveling, everywhere you are using the electromagnetics. Electromagnetics of different wavelengths, that is the different parts, that is they are using it. Now, all this, whatever you are using, that is the part of the electromagnetic waves. They differ from each other only in the wavelength. The nature of waves is there everywhere, it is the same, only the difference is there in the wavelength. Now, just because I see a lot of the students are there, I like to mention the electromagnetics. It's basically, this is a coupling of electric field and the magnetic field. And I'll come, that is the pioneering work by J.C. Maxwell. He is the father of electromagnetics. In 1986, that was his theory, that is, this is the beginning of the electromagnetics. That is, he proved mathematically that okay, there can be a wave electromagnetic which can propagate in free space. Now, as I said, this this electromagnetics, that is the father of electromagnetics is Maxwell. Just I'm going to click.
So arrow click.
Yes. So this that Scottish physicist So whatever the electromagnetics, the basic theories of, or basic that postulates of, that is that Ampere's circuitry law, Faraday's laws of electromagnetic, all these things he put in 4 equations. And his basic, that is the contribution was just you can go to that. Yeah. Yeah. So his basic contribution was there a term called the displacement current density. So to the displacement current density, he was able to couple the electric field and magnetic field and to derive the wave equations. And through this only it was possible to predict that, okay, there is the electromagnetic fields. You can go back to. And 20 years after he invented he discovered mathematically, theoretically, that is the existence of electromagnetic fields. After that, in 1886, that is the Hertz. You can just click on that. Yes. So it is a German physicist. He made an experimental setup. That is the, you can see, he has put this is a dipole antenna. And he was able to produce this electromagnetic pulse, that is the spark, and he was able to receive it to a distance. So through this, he proved the theory of Maxwell, that is, okay, the electromagnetic waves can propagate through free space. And just you can go back. And after that, in 1800, it is a matter of great proud for us, that is that Indian scientist, Sir Jagadish Chandra Bose in Calcutta, he was able to produce electromagnetic waves, and that is the propagation of information. And that too at that time, that is in 1894, he was able to demonstrate electromagnetic waves of wavelength 5 millimeters. So you can just, but unfortunately this is the contribution of J.C. Bose. That is not reported in the textbook written by all those American and European people. Like if you see the Balani's book, Jordan's book, then Krauss' book, nowhere this is mentioned. And after 100 years, that is in 1998 and 2001, that is that IEEE, few scientists from the IEEE, they realized that whatever that Marconi used, that the receiver, that's coherent receiver, that was actually the invention of Sir J.C. Bose. And you see this, he's published a paper in IEEE by Professor P.K. Banerjee. This is the paper. Apart from this, there are many papers. And in IEEE in 2000, there was a special issue on the discoveries of Sir Jagadish Chandra Bose. So, So in 1901, that is the Marconi. You can just click again. Marconi. So like Professor J.C. Bose, he worked on millimeter wave, and that Marconi's experiment, it was that wavelength was around, it is not exactly known what was that frequency used, but the size of the antenna and all these things, it is assumed that he has used something like some 820 megahertz, that was the frequency he has used. So that is that famous experiment, or the transatlantic experiments, where he used this type of, that is the monopole antenna, to transmit this information, that is voice signal over the Atlantic Ocean. So these are the pioneering work done by those days, some 100 years, more than 100 years back. And in World War II, that is that the microwaves, that is the need of microwaves. You see that as the wavelength decreases, frequency increases, that the radar, especially the radar, what needs, you need when it is a wave affair. So what is needed, that is the size of your system should be smaller and smaller, so that it is portable. So this was the motivation in the World War II to go for the microwave technique. And especially this wavelength is the antenna size, is the function of wavelength. higher the wave, lesser the wavelength, the antenna size is also the smaller. So this is the beginning of. Then after the World War II, that is the development. It's communication. That is that electronic communication is started with again with the microwaves. The microwaves give you another advantage: the bandwidth. Higher the frequency, the more will be the percentage bandwidth. And that microwaves not only it's this communication and radar, its application is there in the remote sensing, and I'll cover some of these applications in this presentation. So you can go to the next slide, please. So this is just a broad spectrum of the electromagnetic spectrum. So it starts with a very large wavelength to very teeny wavelengths. So each wavelength of the electromagnetic spectrum or electromagnetic brings to us unique information. So that universe, everything, whatever universe we know, that I can get the study of the radiation from emitted from the object in the space. So as you see, that is the total spectrum is divided into different, like starting with the radio, then microwave, infrared, and up to the gamma rays. So these are the things that the bands which that we are using. But electromagnetic spectrum, you can say it can be infinite, starting with the zero frequency. Next, please. Okay, you can skip to you can go to the next place. Now this the radio waves. So radio waves, these are the frequency bands it is used in the radio frequency. So starting with the very low frequency to that is super high frequencies. So these are the frequencies, and each frequency band is having different applications. Like when I am using a low frequency, so marine type of communication, and suppose the communication underneath the sea water, so we go for a very low frequency. And for radio frequency, you can go to high frequency. For television, you can go VH frequency, like that there are. And for mobile application, like here, different frequencies, different period, and for different service providers, so it will be having the different frequency band used, starting from 800 megahertz, 1.8 gigahertz, like that. Okay, next please. So already I discussed about this. These are the different, that is, it is the broadcasting, then it is the communication, and then radio control, and then radio frequency identification, MRI scanner. So this is used in medical that is the magnetic resonance imaging scanner. So there the magnetic field, the resonance of magnetic field and radio waves are used to detect or to get the images of your brain or this of the bodies. Okay. Now coming to the microwaves, because this is the theme of the microwaves. The microwaves having a lot of applications. It started with the radar. Rather than communication, the remote sensing, then it is the defense, high-speed circuits, then the astronomy. Okay. Now next please. Now starting with the domestic use, that is the microwave oven, and that was invented accidentally. When Dr. Baron was Spencer, he was working on a magnetron, and he discovered that the candy bar in his pocket got melted. And then he experimented with some other food products like popcorn and eggs, and realized that microwave can cook food very quickly. Because the food material, whatever you use, these are all the lossy dielectrics. And whenever the microwaves is passed through the lossy dielectric materials, the heats get generated. So that operational, that is the domestic microwave oven, it was that improvement was done, and it came into existence in 1967, and now we get a wide variety of microwave ovens, and basically they're used in the S-band. Now microwave and radar, so this is I have shown that two types of radar. There is a bistatic radar and there is a monostatic radar. In the bistatic radar, you will have a two transmitter and receiver. They are different. So then you use two antennas, different antennas. And in the monostatic case, only one antenna is used to transmit and receive the electromagnetic pulse, or it can be a continuous wave electromagnetic pulse. Now, the importance of microwave is, you can just, I have shown it with the two graphs. You see, when the antenna size is bigger and bigger, you will have this antenna beam width, that is a narrow radiation pattern. So when the radiation pattern is narrow, so the target identification, a smaller target can be identified. So when the requirement is there, that is the surveillance, or whenever we want to detect a target of the smaller size, we need higher and higher frequency. So what we can do, we can increase the size of the antenna, or we can increase the frequency. So that's the importance of the microwave, and that was it came into existence in the World War II for the Now this is the application that is direct to home, that is a DTH. So generally the K-band satellites are used, where you can use, that is the K-band microwave signals, that is from the earth station through satellite directly to your home, and you can watch all the TV programs to your set-top box. Okay. Next. Now microwave communication. Now why microwave communication is important? Because you see that whenever we do a electronic communication, we modulate the baseband signal. So the modulating signal, if it is the microwave, and since the microwave has the wider bandwidth, so the number of channels, I can increase the number of channels in the microwaves. So this is the importance of the microwave communication. I can have the more number of channels as compared to the lower frequency bands. Next please. But this is the disadvantage of microwave signal, that is the electromagnetic signal at micro frequency, is that they penetrate to the ionosphere. So like the radio waves, that is up below, that is very high frequency VHF, what is possible that the electromagnetic waves, they get a total internal deflection from the ionosphere. But in this case it is not possible. So what we need, that is a point-to-point communication, like that is the line of sight communication. So the line of sight communication, the disadvantage is that then I need that is man-made noise, and when there is buildings or trees, it can affect the signals. Now the solution is the satellite communication. Now in satellite you can use as a repeater station. Yeah, next please. So as I say, the electromagnetic signal at micro frequencies, it cannot be reflected from the ionosphere. So if a satellite is there, so satellite will amplify it and it translate its frequency and it will send back it to another earth station. So like that you can communicate between the two stations through a satellite. Yeah, next please. Now satellite microwave communication, that the concept was given by a fusion article by Arthur C. Clarke in 1945. And today the satellite communication, it's a wide variety of services, starting with the broadband communication, then audio and video distribution networks, navigation, different types of navigation, whether it is a maritime navigation, or it is a land navigation, or it is a space navigation, whatever it is, the satellites are used very widely. And the worldwide customer service and support, as well as the military command and control. Okay, next please. Now what are the different categories of the communication satellites? So depending on the coverage area, like the global satellite. Global satellite, it is like Intelsat, Inmarsat, all these are the global satellite. It's give you a global communication. The regional communication, like it can be a South Asian country, that is the SAARC countries, the satellite can be exclusively for these regions. And national satellite, like our INSAT, Indian National Satellite, INSAT. So these are the different characterization of satellites. Now the service type. So service type is the fixed service satellite, FSS. That is a point-to-point communication. Now the broadcast satellite, also called it is the DBS, direct broadcast service. So example is satellite television and the radio. And the third category is the MSS type, that is the mobile service satellite. So here it can be an example of the satellite phones, then distance alert, and that have been used for that distress alert also. These services are the mobile MSS type of satellites are used. Okay, the general use is the commercial, military, amateur, and science, or for all the satellites are used. Next, please. Now again, these different satellites are used in the different types of orbits. So it can be circular, elliptical, and when it is a circular, this it's the circular orbit. The center will be the Earth center, and when it is an elliptical orbit, so elliptical orbit, the foci of this ellipse will be at the center of the Earth. Orbit around the Earth in different planes, like equatorial orbit, geostationary orbit. So this is equatorial orbit. Polar orbit, when it passes through both the poles, and other orbits referred to as the inclined orbits. Now again, the altitudes of the satellite, it can be geostationary orbit, when it is 35,000 kilometers. In the equatorial plane, we call it geostationary orbit, then medium earth orbit, and the low earth orbit. Next, please. Now, geo-orbit advantage is that the tracking of the satellite is simplified, because the satellite is the Earth rotation, that is the period of the Earth rotation, and the satellite, it is revolving around there. So this is the same. So as if the satellite, it is looked upon, that is, it is like a stationary with respect to your Earth station. So the tracking becomes very simplified, and it's a very high coverage area. Now what are the disadvantages? Because weak signal after traveling cycle. So you need a system where that your signal to noise level. So this type of that hardware should be of very sensitive hardware for this when the satellite is in the geo orbit. And polar regions are weakly covered. Okay, next please. And these are the different frequencies. You see all the frequencies are, there is a microwave frequencies. These are used for different services. L band generally, UHF band. UHF band is the voice communication, and for some military applications it is used. So this is the UHF band. Our GSAT-7, that it is GSAT-7 UHF payload is being planned. And L band is the mobile satellite services, and S band, it is 2.5 to 2.7 gigahertz. There it is mobile satellite service and broadcast satellite service, deep space research. All these are used in this frequency band. And C band, so there are three bands are used. There is the normal C band, lower extended C band, and upper extended C band. That is again used for the fixed satellite service. X band, it is 8 to 12.5 gigahertz. There again it is for fixed satellite service, then terrestrial images, military and meteorological satellites. Q band, it is direct to home, the DTH, and broadcast satellite services. And that is the Ka band. Ka band again it is 17 to 30 gigahertz. That is again, it is fixed satellite service and the multimedia satellite services. And Q band, it is 38 to 44 gigahertz. So these services are again the fixed satellite service, and when the very high data rate communication is needed, so these frequencies are used. Now coming to the microwave remote sensing. So this figure, it shows the oxygen and the that is the water vapor. That is the absorption characteristics of the microwave frequencies. So you can see that the absorption, it is selective. It is at some frequency the absorption is very high. So this is the when this molecular that absorption is where it is absorbs the high, so it radiates also. That is, that radiation is also very, where the object which absorbs maximum, it radiates also maximum. So these are the frequency bands used, especially the atmospheric studies. like different frequency bands that are used. That is that these things are used to know what is the humidity profile if I want to know. So this is the frequency band like 23, 183. These are the frequency bands used for the sensors, a humidity sensor, and 60 gigahertz, and all these things are used for a temperature sensors. Now, 1 minute, just yeah. So there are two types of, that is the remote sensing sensor, that is the passive sensors and the active sensors. The passive sensors, it receives the thermal radiation, that is the black body radiation. So these are the radiometer, sounder, synthetic aperture radiometer, and active, that it transmits and receives the microwave pulses. So these use a imaging radar, that is the synthetic aperture radar, scatterometer, altimeter, etc. Yeah, next please. And radio astronomy, again as I said, that is that all the bodies know whenever its temperature is above 0 degree Kelvin, it radiates. So that's the radio astronomy. They use a very sensitive receiver, and that is called, that is that radio interferometry is used generally for this, and a lot of arrays of antennas, that is the thin array, white array. This is a photograph I had taken from the GMRT, and these antennas, it is a 45 meter size antenna, and these are used to receive a very weak signal, that is the cosmic radiation, radio sources. So these are used, and they are processed, and based on this, that the thermal profile, the studies of the cosmic radiation, that is, it is being studied using the radio astronomy. And the frequencies are used, the various frequencies are used up to 20 gigahertz and even above that also. Next please. This is the another application of that microwave, and so this is basically a radiometer. This is a thermal profile. So depending on the different material characteristics, the radiation will be different. So from that different object, like you can say a revolver is hidden, you can know that it's from the processing of the that radiometer data. So these are one of the application of microwave millimeter application. Similar applications are there in the medical science also. I'll come next to that. Next please. Mobile communication. Now this is very important. All of us, we cannot think our life without a cell phone. So here also there is the microwave frequencies are used, and there also the different frequency bands are used. That is by that ITU regulation. So here your mobile phone is basically a transmitter and a receiver. You are able to communicate as well as receive the microwave signals. And there are a lot of discussion on about the health hazards of the microwave. That is the radiation from the cell towers. Okay, so this is a controversial topic, I should say, whatever is being claimed and whatever this is said. So there is no proof also that, okay, the microwave is causing radiation, but there are a lot of concerns about that specific absorption radiation of this thing. I am not, because I do not have any proof of all this thing, I do not have much literature, I will not comment on all this thing, but some people in India, they are working on all this thing, that is the safe uses of microwaves for the mobile communication. Next please. High speed circuit. Now as all the digital devices, the clock speed is increasing. Now it is going even more than that is a gigahertz. So microwaves come to picture. Now as when your wavelengths become comparable to the size of your circuit, so that first of all the behavior of the dielectrics, that is the used in the circuit, so that will that is well behaved when your frequency is a low frequency. But you go to the very high frequencies, you really need the material characteristics at those microwave frequencies, and accordingly the circuits have to be designed. So there it needs, that is the microwave analysis, the field analysis of the circuit, generally the circuit analysis, when we do the circuit analysis, we do not do the field analysis. The concept is like that the electromagnetics, I can express it in terms of voltage and current. But when it is the, your circuit size is comparable to the wavelength, so there is voltage and current concept will not work. So there we need really to calculate the fields. Nowadays a lot of electromagnetic tools are available. With this thing, the high-speed circuits are analyzed and they are designed accordingly. Yeah, next please. Now defense application, this is very important application. Now the electronic warfare, so very sophisticated the radars and very high precision radars, and they have been developed and being used. And this is only because of this, there is the microwave and I think very high frequencies are also used. And various types of surveillance radars are being developed in India also. That is Defense Research Organization, they are doing a lot of research. But still we are not self-reliant in this field. A lot of radars and all this are being imported. Hope that is, with the efforts are being put, that we will attain the self-reliance in this field. Next please. Now the biomedical applications is a very important applications because the microwave has the, as I said, the property that it can, depending on the dielectric constant, like you see, whenever that cell, no, when there is some malignant cell and there is a change in the behavior of the cells, the dielectric properties will change. So basically the microwaves can be used to detect those cells. Okay, and then even that microwave radar can be also used to detect some malignant organs or like that. So these are all the medical application of the microwaves. Next please. This is a very new field that has come. You see that all these our satellites, they need a thruster so that we can control the satellites when it is in the orbit. The disadvantage of it, the satellite must carry a lot of propellant for it. So if the satellite mass, the total mass, that is depends on the total mass of the propellant.